Hello everyone. My name is Dr. Nagaraju, working as assistant professor in the Department of Computer Science and Engineering A&ML branch in the Institute of Aeronautical Engineering, Hyderabad. Today I am here to present a topic called as a state space search. So before moving into the topics, let us try to see the list of the topics what I am going to cover in this session. One is, first I am going to cover the introduction to the problem solving, and then we will try to see the state space and its representation with some suitable examples. So in the earlier session, means before this video, we have done a video which is related to the introduction to artificial intelligence. So in that video, we have seen a definition of artificial intelligence, saying it as AI's main intention is to make, or we can say, to mimic the behavior of the humans in the machines. Means the main intention of artificial intelligence is we have to showcase, or we have to make the machines to behave in the same way as the humans are behaving. Means the machines has to behave in the same way as the humans behave while solving the problems. Means just like we can say that the artificial intelligence is making a machine to make a substitute of a human, we can say. Means with the help of this artificial intelligence, we can the humans itself are trying to create some kind of substitute to them so that they can solve the problems within the shorter period of time. So we can say that here we may get a doubt. So why we need these AI machines in place of humans? So as we know that humans can also are so intelligent, and they can exhibit their intelligence in solving most complex problems. But there will be some kind of problems which are going to take a lot of time to complete its solving. So in that case, we can say that we should suppose to have a substitute which can solve the problems in a given shorter period of time. Okay, so in that point, means in order to solve the most critical problems in the shorter period of time, we can consider that humans are trying to create the substitutes. That is nothing but the machines which can exhibit the intelligence. So that's why the definition of artificial intelligence is telling that the main intention is we need to showcase, or we need to show, or we need to make the machines to think and behave in such a way that how the humans are doing nowadays. So that is a definition we have seen in the earlier case. So in this video, we are going to cover the other perspective of the artificial intelligence. So if you think of this artificial intelligence not as a part of the behavior showcasing, but we will try to see the artificial intelligence in respect of problem solving. Means our today's video totally concentrating on this particular aspect, which is called as here the problem solving. Means we are going to talk, or we are going to consider this artificial intelligence implementation in terms of problem solving. So what do you mean by problem solving here? As we know, even the humans or the machines, the problem solving will be in the same fashion. What is that? Especially you take any of the kind of problem. So what happens? There will be a given state. There will be a given state for any kind of problem. So what main motto is, from the given state, we have to move to the desired state. I am repeating these statements once again. You see, in the artificial intelligence, the other perspective is the problem solving. So in problem solving, mostly for every problem you take, you consider that for that one, there will be a given state. To that given state, we need to move to the desired state. Means the given state means the state will be given initially, we can say. From that initial state or the given state, we need to move to the desired state. Then we can say that we have solved the problem successfully. So during this move, what we have to do is we need to make the decisions. Okay, we need to make the decisions. Means once the decisions is taken, it will makes us, right? Us means here it can be human, or it can be an artificial intelligence agent. So here we talk about in terms of the artificial intelligence agent. So the AI agent, in order to solve the problems, first a given state, a state will be given. We call that state as an initial state, and from that initial state, it has to move to the desired state by taking the decisions in between. Okay, so the biggest question comes is how these decisions can be made. How these decisions can be made, right? As we can say that the decisions can be made based upon the knowledge base. The decisions can be made based upon the knowledge base or based upon the search. Okay, means whenever we need to know how the decisions are taken in order to move from the given state to the desired state, so we should suppose to know what do you mean by this knowledge base and what do you mean by this search process. So in the knowledge base especially, there will be two kinds of things will be there. One is called as the memory based. One is called as the memory based and another one is called as the rule based. Memory based and rule based. So in this particular video, we are not going to concentrate on the memory based, rather we are going to concentrate on the rule based. So what does it mean? What does it mean that rule based decisions we can say? Means when the AI agent has to apply or has to consider the rule based things so that he can make some kind of decisions and he can move from the given state to the desired state. So what do you mean by these rules here? Okay, here rules are nothing but we can say some kind of conditions we can say. Right, rules are nothing but some kind of conditions, or otherwise we can say sometime in some problem solving it will be called as some kind of actions, right? And in some problems it will be called as some kind of a legal action, legal moves we can say, legal moves, right? Means whenever the AI agent applies certain kind of rules, so what happens, that rules will makes the AI agent to take some kind of decision. So that decisions will make the problem move from the given state to the desired state. The biggest question comes is how these rules are given, means how we are going to get these rules. So as I mentioned here, the rules are going to come from the knowledge base. Means the knowledge base we can say it is kind of a database or a repository where we are going to see certain kind of rules. So these rules, and even sometimes these rules we can call even call it as operators in some problem solvings, in some kind of problems. So these rules are applicable in the they are available in the knowledge base. So what the AI agent will do, whenever he wants to move from one given state to the another state, he is going to pick up one rule that is present in this knowledge base and he will apply that rule to a particular given state. For example, think that my given state is some IS, which is the initial state. So my goal state is somewhere else. My goal state is somewhere else. So what I have to do is, what the AI agent has to do is, he has to move from this state to this state. So in order to make a move, what the AI agent will do, he will try to select a rule that is present in the knowledge base. So that rule will be applied to a given state. Means for example, it is the initial state. So in that case, what happens when this rule is applied? Okay, so the output of that rule can be the possible states. We can say that they are the successor states. They are the successor states, or otherwise we can say that they are the neighboring states. Okay, they are the neighboring states. So whenever a rule is applied to a particular state, it is going to result in the successor states, or otherwise we can say that they are the neighboring states. So all the possible, we can say here it is not one successor node or one neighboring node, but it is all available, mean all we can say all possible successors we can say. Means in this case there are 4 possible successors are there. So which one we are going to select, that depends upon the problem we are dealing with. Okay. So it is very important thing in order to make a decision. Means once the decision is taken, then the AI agent can move from one given state to the desired state. So for taking such kind of decisions, he is making use of the rules that are available in the knowledge base, and he will try to apply that appropriate rule to that particular state, and he will try to move to the other states. So this process is going to continue until the AI agent is going to reach to the goal state. Okay. So the biggest question comes is, so what happens if the rules are not available in the knowledge base? It does not mean that every time for each and every problem we are having, the rules are applicable, the rules are available. What happens if the problem statement is very new and there is no specific rules present in the knowledge base? Then immediately what we have to do is we need to go for the search process. So during this search process, we need to create the knowledge. We need to explore some kind of knowledge so that knowledge can be converted into rules. So in very much clearly we can say that either you are performing the search process or whatever it may be, whenever the AI agent wants to move from the given state to a desired state, it should supposed to have the knowledge base. Should supposed to have the knowledge base. If the knowledge base is available and that knowledge base is suitable to the problem we are solving, then directly we can pick up that appropriate rules and we can apply to the given state. But if such knowledge is not available, then our process is we need to perform the search activity. During the time of search activity, we are going to take up or we are going to identify the new knowledge related to the problem. So that new knowledge again we are going to add up to the knowledge base. So we can say that it is an iterative process, means adding a new knowledge to the knowledge base is nothing but a iterative process where repeatedly we need to identify the new knowledge and we need to keep on adding them. And sometimes we need to modify the existing knowledge also. So whenever such kind of knowledge is available, then those knowledge we are going to convert into rules. So these rules can be an operator, it can be some kind of condition, or it can be a kind of action, or it can be some kind of legal move. So these kind of things we are going to apply in order to make the decisions. So whenever we are selecting an appropriate rule, definitely our newly coming state definitely will makes the AI agent to move towards the goal state. Okay, so this is the entire explanation we can say about this problem solving. So let us try to understand the things based upon this problem spaces and such. So as I mentioned earlier, to build a system to solve a particular problem, we need to have four things. Means four things are very, very important in order to write a AI program which can exhibit some kind of intelligence during the problem solving. So the first important step is we need to define the problem very precisely. So what do you mean by this? Defining of the problem is nothing but what is the initial state, means what is a given state, means what state is given to us, and what will be our desired state. Desired state in the sense the final state. So in the while defining the problem statement, we should supposed to include the specifications of what the initial state will be, and also we need to include what final situations that constitute acceptable solutions to the given problem. So these two things need to be included while defining the problem statement. And our next step is we need to perform the analysis. Analysis in the sense we need to identify the appropriate techniques that are already available to solve the problems. So if such kind of techniques are already available, then which one is the most efficient one? So that verification we need to perform while performing the analysis of the given problem. Next, we need to isolate and we need to isolate and represent the task knowledge. Okay, knowledge that is necessary to solve the problem. Just now we discussed, means our primary duty means once we define the problem and once we identify the available techniques and once we select a specific technique which is more appropriate to our problem statement, then our concentration should be on the knowledge base. Why? Because until and unless we have proper knowledge to solve that problem in the knowledge base, you cannot able to solve that problem. So our once the analysis is completed, our next duty is we need to isolate and represent the knowledge which is related to solve that particular problem. And then, right, once the means here during the analysis we have seen only the appropriateness of various possible techniques. But in the fourth step, means while choosing the best problem solving technique, here the specific selection of a particular technique is important. Means if you select a very perfect technique to our problem solving, then easily we can solve the problems. Okay, so how can we know that we have selected a very best technique in the sense? So we can say that here problem solving techniques, choosing the best problem solving techniques. So here actually there are two different kinds of problem solving techniques will be there. We can say even these things are the search techniques. Why they are search techniques means most of the AI problems are related to the search activity. So the problem solving techniques in this specific module, we can say that there are of two types. One we can say that uninformed, and another one is informed. Okay, so these search techniques are uninformed and informed. So what do you mean by uninformed? So when the specific techniques are uninformed, that means that we are not going to get any additional knowledge. additional knowledge about the problem statement. That means that you are not going to have any knowledge related to the particular domain. So that's why we say that without having any specific knowledge or any additional knowledge about the domain, still we are able to select this particular technique. So we can say that this informed search techniques are the blind search techniques. But when it comes to informed search techniques, so we are going to have the specific knowledge about the domain. Means we are going to have some additional information about the problem. So with the help of that additional information, we can easily solve the problems. So in this case, we can say that it is nothing but heuristics. We are going to get some additional information which is called as heuristics. So heuristics can be at the distance, means there some heuristic function we are going to apply, h of x, some h of x. So this heuristic function is going to produce us some kind of a numerical value. It can be considered as a cost, it can be considered as a distance, or it can be considered in sometimes it is as a weight, like that. Okay, so choosing the best problem solving technique in the sense, you need to identify whether your problem statement is related to this uninformed or whether related to this informed. So if it is uninformed, it is nothing but some blind process. Means here we cannot guarantee that we are going to reach the goal state. Even if we reach the goal state, that we cannot say that it is not the optimized solution we got. Okay, but anyhow, even the informed search techniques are also applicable to some kind of problem solving statements. Okay, so other one is which is called as the informed search techniques. So most of the popular techniques are the informed search techniques only, where we are going to get a very good solution, we can say, which is a very optimized one. For example, think that you are trying to identify a shortest path between the given points. So if you do it by this uninformed search, it will be very difficult. Means we cannot guarantee that the path what we got from the initial state and the given state is the optimized one. Optimized means here the shortest one. So in that case, we need to select. Means for such kind of problems, we need to select the informed search techniques. So informed search techniques will definitely give the shortest path between the given points. So because of these things, we can say that choosing of the best problem solving technique is also very, very important. Once you choose such kind of techniques, then we need to do the applying of such techniques to the problem we have. So these are the 4 steps. The first step is we need to perform the definition. Means we need to define the problem statement very precisely. The second one is we need to analyze the problem. Next, we need to isolate and represent the knowledge related to the problem statement. If knowledge is already available in the knowledge base, you can directly use it and you can apply to take decisions. If such kind of knowledge is not available, so you need to go for identification of new knowledge, and that knowledge need to be added to the knowledge base. And next is you need to perform the selection process, which is nothing but selecting the best problem solving technique and apply it to the given problem. So let's talk about the problem as a state space search. So in the earlier case, we have discussed the problem in a general way. So we need to consider why, because if you want to write the AI program, it's not a that much easy process. So before that, we should suppose to understand the environment where generally we are solving the problems. Means it's we can say that it's some kind of visualization where we are going to see the initial state and the goal state, and also in between the possible states. Means what are the states that are making us making an AI agent to move from the given state to the desired state. So for understanding such kind of environment, let us try to define the problem as a state space search. So for this one, we need to know we have to select a particular a problem, then only it will be very clear how we can define the problem in the form of a state space search. For that one, I am selecting a problem which is called as playing of chess game. So if you are writing a AI program, means if you are trying to write an AI program to make the AI machine to play this kind of chess game, so our first primary duty is we need to specify the starting point of the chessboard. The starting point of the chessboard means where the actual chess playing game will start, from which position we can say. So once that is identified, our next duty is we need to specify the rules that are defining the legal moves. Okay, first we are identifying the starting point, and then we need to specify the rules which are applicable to the chess playing game. So how many number of possible moves are there. So for those number of possible moves, we should supposed to write the rules. And the next, we need to identify and or we need to represent the board positions, so that we should supposed to tell at what point we have won. Means at what point the AI agent has won the this chess playing game. Okay, first we mentioned that we need to specify the starting point, then we need to specify the rules which are required to make a legal move, and then we need to specify the board positions, right? Especially means the board position which is going to tell whether the opponent or the one side has won the game. But here you try to understand legal moves. We are specifying the legal moves. Specifying of legal moves, it's not it is not only the one important point here. Why? Because here along with the specification of legal rules, even we need to specify when the game has completed. When the game has completed, that one is also very, very important. That's why we say that in addition to these representations or these specifications, we should supposed to explicitly state our objective. What is our objective? When we have means when the AI agent has won the game. So for that one, so this can be done. Okay, so this can be done through the creation of rules that clearly define our goal. Means we should supposed to write the rules which is going to tell about the initial state where we are starting the game, and we have also need to write the rules which can tell that where we have completed the game. Means where we have won. Means that is nothing but here explicitly representing the our primary objective. Okay, so but here there are some kind of complications are there. There are certain kind of complications we can say. Why? Because it is not that much easy in order to write the legal moves for the chess playing game. So why? Because why it is like that means whenever you are selecting a particular selecting this chess playing game, so we know that it is represented as a form of some kind of okay matrix which is of 8 by 8 8 by 8 matrix, or we can say that it is a 8 by 8 array. Okay, so in this 8 by 8 array, so what are the problems we are going to face is we can say for each and every move, means for 8 rows and 8 columns, so how many combinations are coming? For all those combinations, they will be called as the board positions. So for all those board positions, means board positions for each and every coin in the chess. So for those board positions, we should supposed to mention the rules. We should supposed to mention the rules. That's why we say that first we need to, means before writing the rules, we should supposed to provide the formal and complete problem description. Problem description in the state. In the case, we can say that it is nothing but the starting position of the chess game, playing game, which is represented or which is shown as a 8 by 8 array. And for each and every position, okay, we can say that for each and every position, we should supposed to represent with a kind of a symbol. And then we need to define our objective also. We need to define an objective that is nothing but some kind of board position where the opponent is not having any kind of legal moves. That means when the opponent is doing some kind of attack on the king of the other side, and if he is not having any legal moves to perform, then means that it means that yeah, we have reached to the goal point. That is nothing but here the defining of our objective. So the legal moves, it is going to provide the way of getting from the initial state to the goal state. Okay, so initially we have said that the rules, the appropriate rules application will make us to move from the initial state to the goal state. Okay, so in this case, these rules we are going to talk in terms of the legal moves, we can say. In terms of legal moves, right? So these legal moves representation is very, very important in order to make the AI agent to play the chess game. But let us try to see one example here. And this is the example, this is a figure I have taken from the textbook, right? Which is one legal chess move. So this is the initial state given to us, and this is the next state thing that. Next state means in this case what happened, we have moved from this place to this place, this particular coin. Okay, so what we have done, we have performed one legal move. So in order to perform this legal move for an AI agent, you should supposed to write a appropriate rule. Means that rule, whenever the AI agent applies, then he can make this soldier move from this point to this particular point. Like that, how many number of board positions are there, means how many number of possible positions are there. For each and every such kind of possible positions, you should supposed to write the rules. So for how many possible board positions are there? There are 10 to the power of 120 possible boards positions are there. So 10 to the power of 120. Okay, 10 to the power of 120 is not a simple number. Okay, when you elaborate it, it will become a very big number. Means those number of rules we should supposed to write in order to make an AI agent to play the chess game. Doing that, he has to perform the legal moves and he has to win the game. But there are a lot of complications that are going to arise when we are going to write these number of legal moves rules. Okay, what are those? Let us see. So we can say that there will be no such kind of person who can supply a complete set of such rules. Means writing the rules of 10 to the power of 120, we can say that it is not a simple task. So we can say that there is no such kind of person who can provide the complete set of such kind of rules. And even if any of this person is trying to do it, it is going to take a long time. And we cannot guarantee that he is going to write all the rules without doing any kind of mistakes. And even if such kind of rules are written in any of the means, it will be very difficult for us to handle them. Why? Because whatever the rules that are represented, which are of 10 to the power of 120, those rules again we need to represent in the form of a program. So the program itself is going to become more complex. So a simple scheme, means a simple kind of representation or a simple kind of technique is required in order to represent such kind of large number of moves here. But even if you could able to identify such kind of simple technique, so it will be very difficult even to store those number of rules. But still there should be a simple method. Okay, instead of representing the rule in the complex way, means we can say in the more specific way. Means instead of writing the rules in the more specific way, it's better to represent all the rules in the generalized way, so that those rules can be applicable to any kind of problems. So that specific way and generalized way we are going to see in the upcoming modules anyhow. So we need to look for a way, means we need to write the rules which are going to describe all the legal moves. So that should be done in the generalized way. So for doing that, we need to introduce some kind of convenient notation for describing such kind of patterns and such kind of substitutions. Okay, but anyhow, in the upcoming modules, we are going to take some examples and we will try to see how these convenient notations will be and how the convenient notations can be represented. Why? Because there are two different types of logics we are going to see in the upcoming modules, which is called as propositional logic and predicate logic, where we are going to represent the rules in the simplified way. Okay, so let us try to define the problem as a state space. So define the problem of playing chess as a problem of moving around in the state space. So here we need to understand what do you mean by this state space here. If we talk about this chess playing game, here our state space is nothing but the 8x8 array. It is nothing but the 8x8 array. So first we are going to define this particular state space. And for each and every state, okay, corresponding to it, we need to represent the legal position of the board. Okay, so next we need to play the chess by starting at the initial state and keep on applying some set of rules and try to move from one state to another state. Okay, means when we are selecting the appropriate rules or when we are selecting the perfect rule, means which is suitable to that particular situation or to that particular state, then definitely it will make, means the application of that rule will make to move towards the goal state. So finally, attempting to apply such kind of appropriate rules definitely will end up in one of the state, which is nothing but the final state. Means identification of trying to understand here, you see why we are defining the problem as a state space is that is important. First, we are trying to understand what is the environment. What is the environment where we are moving from the initial state to the goal state or from the given state to the desired state, and how the decisions are making. So the decisions are completely done based upon the rules. So how the rules need to be applied, that we are trying to understand here. Okay, so here we can say that this triple S is nothing but state space search here. state space search is nothing but the structure, we can say, structure where we are going to represent, okay, in two different ways. Okay, one is we need to we need to do such kind of representation by creating a formal definition, just now we discussed. And then we need to allow the AI agent, okay, allow us means here, sorry, it's not an AI agent, it's a human. We need to allow the human to specify the necessary actions to solve the issue. Okay, so specifying the necessary actions is nothing but the legal moves, we can say here. So those legal moves are going to permit us in order to define the process of solving, we can say. Okay, so we can consider even this is means the defining the process of solving is nothing but including about some kind of techniques and also some kind of search process. Okay, that's why I mentioned that selection of the appropriate technique is very, very important. Then also to perform the search process is also very, very important in this case. So the general technique, we can say, means when we are solving this AI kind of problems, the general technique of exploring the space, means the state space, is nothing but trying to identify some kind of path between the current state and the goal state. Okay, means if you are dealing, means if it is not the chess playing game kind of thing, if it is a traveling salesman problem, and if you are trying to understand the state space representation of that problem, then it is nothing but the specification of your problem in terms of identifying a particular path from the given state to the goal state. So that's why we say that every time, means in most of the AI problems, we say that it is related to the search activity anyhow. That's why search is a very important process, we can say, in the solution of hard problems for which no direct techniques are available. Okay, so that's why we say that in each and every AI technique, almost more than 90% of AI problems are related with this search techniques or search process, we can say. Okay, so we have tried to understand the state space representation, and let us try to take one example so that it will be very clear why this entire explanation we have taken here. Okay, so what we have done in the initial, means before this particular slide, we try to understand how this state space representation of a particular problem can be done. So we came to know that first we have to identify the problem, define the problem statement, where we need to mention the initial state and the goal state, and in between what are the applicable solutions, means what are the possible actions we can take. Okay, so I'm going to consider one particular example which will make us more clear how the problems of AI can be solved by this problem solving state space representation. So the problem statement is here, you see, we have given two jugs, means two jugs are given to us. Okay, one jug capacity is of 4 gallon and another jug capacity is of 3 gallon. So we can say that there are no any markings on this particular jug, means there is no such kind of measurement marks on this particular jugs. Just only we are having an information that is a jug is capacity of 4 gallon and another one is of 3 gallon. So there is a pump, means a pump is there. So using that pump, okay, we can say using that pump we can take water, we can fill the water in these two jugs. So what is our goal? Means the goal is, for that goal, first of all, try to understand what is the initial state given to us. The initial state is two jugs is given to us. One is a 4 gallon and another one is 3 gallon. Both jugs are completely empty. Means empty two jugs are given to us, and we have given a resource, that is the water pump through which you can fill up this water. So that is the given state. This is our given state, we can say. So from the given state where we have to move, we need to move to the desired state. So what is the desired state? Means what is the expected state? That is, we need to fill exactly 2 gallons of water into the 4 gallon jug. Means you should supposed to fill, means we can say this is a, you should supposed to fill this jug with some exactly 2 gallons of water. 2 gallons of water. But okay, so in between, means from the given state to the desired state, if you want, in between you should supposed to apply the rules. Okay, so we will try to see how these rules will be represented in the knowledge base and how these rules can be applicable or applied in order to move from the given state to the desired state. So the most important point you need to understand here is, okay, we don't have any markings on the jugs. Okay, so how we are going to come to know that exactly we have filled this 4 gallon jug with 2 gallons of water? So that is very important here. Okay, we will try to see how this rules representation will be there for these problems. Okay, so a water jug problem, we can say it is a state space for this problem can be described as a set of ordered pair of integers. So I am representing the integers as x comma y. X is for the 4 gallon jug and y is for the 3 gallon jug. So what is the description is telling about the x is going to have either these values 0, 1, 2, 3 or 4. Why? Because x is sorry, x is having the capacity of 4 gallon, and when it comes to y can have the possible values of 0, 1, 2 or 3. So x represents the number of gallons of water in the 4 gallon jug, and y is going to represent the quantity of water in the 3 gallon jug. After defining the problem statement, next our duty is we need to find out the requirements. We need to identify the requirements through which means by taking help of those requirements, how can we solve that problem? So the first foremost thing we need to require is the problem description. So in the previous slide we have discussed the problem description. Once it is done, next our duty is we need to identify the operators. Operators in the sense here it is nothing but some rules. So along with those rules, even we need to identify the control structures that loops through a single cycle in which one rule from left hand side matches the current state is chosen. Actually what happens, we are going to study this in the upcoming modules, but anyhow I will discuss it in a shorter way. So each and every rule we are going to represent as L to R, means left hand side and the right hand side. So this left hand side is going to talk about the current state. It is going to talk about the current state. So whenever you apply this particular rule, means if you feel that this rule is more appropriate to this particular state, to this particular current state, and if you apply, so what is going to be the next state that is going to represent the right side of the rule. So next thing is we need to describe the appropriate change that in the state, in the corresponding that we are going to represent with the right hand side. Just now I mentioned in the shortcut way. That is the left hand side of the rule is going to tell about the current state, and the right hand side of the rule is going to tell what will be the next state when you apply this rule to this current state. So we are going to keep on applying such kind of appropriate rules so that we can move towards the goal state. That's why we say that the cycle is going to continue as long as it does not, means there are no appropriate rules available, or we can say we have reached to the goal point. Let us try to write the production rules. Rules are otherwise we can say they are the production rules. So there are different production rules that are applicable to this water jug problem. So let us try to understand how these representations are done. So what happens if I say 4 comma y? So as I mentioned here, x and y are the integers I am representing for the gallons of jug. 2 jugs. One is for 4 gallon jug it is x, and for 3 gallon jug it is y. So whenever I represent in the production rule as 4 comma y, that means that I am asking the AI agent to fill that particular jug with the 4 gallons of water. So if I mention x comma 3, that means that I am asking, means whenever you apply, it means that whenever you apply this production rule, that means that you are trying to fill up that 3 gallon jug with water. 3 means it is a capacity. So what does it mean if I say x minus d and y? So that means that I am not disturbing the y, means I am not disturbing any 3 gallon jug, but here I have written x comma d. So whenever I mention that one, what does it mean? It means that pouring some water out of the 4 gallon jug. Minus d is representing that removing some water from that particular jug. So if I mention x minus d, that means that I am pouring some of the water from the 4 gallon jug. So if I represent the same thing for y, so what does it mean? I am pouring the water from the 3 gallon jug like that. So here what we are doing, we are trying to represent all the production rules, means the rules which are applicable in order to solve this problem. And next, if I represent 0 comma y, so what does it mean? 0 means I am making the complete 4 gallon jug empty, right? Nothing but empty the 4 gallon jug on the ground. Means if there is any water in that particular jug, we are pouring the water on the ground and making it as empty. So representing that 4 gallon jug with empty, I am using a 0. So in the similar way, if I say x comma 0, That means that I am not disturbing the 4-gallon jug here, but I am removing all the water that present in the 3-gallon jug, and I am removing means I am pouring it on the ground. So what does it mean? 4 comma x minus of 4 minus x. So it is nothing but pouring of water from the 3-gallon jug into the 4-gallon jug. So here you see it is minus. Minus means removing some water from the 3-gallon jug. But where you are pouring it, it is not on the ground. It is not on the ground, but you are trying to pour that water in the 4-gallon jug. That's why we are saying that if you represent 4 comma x minus of 4 minus x, that means that we are pouring the water from the 3-gallon jug into the 4-gallon jug until the 4-gallon jug is full. Okay, right? Like that it will be. And next representation, the same kind of representation here you see. Here I am representing x minus 3 minus of y comma 3. So what does it mean? I am trying to pour the complete water, okay, from the 4-gallon jug into the 3-gallon jug until the 3-gallon jug is full. Okay, right? This is one production rule. The another production rule you see, x plus y comma 0. So I am making the 3-gallon jug empty. So how? By removing all the water present in the 3-gallon jug and pouring it into the 4-gallon jug. That is nothing but here pour all the water from the 3-gallon jug into the 4-gallon jug. Next, if I represent 0 comma x plus y, that means that I am removing the complete I am removing the water from the 4-gallon jug and I am pouring it into the 3-gallon jug. Okay, so until how much to how much extent I am pouring that water until this 4-gallon jug becomes empty. So if I represent 2 comma 0, okay, if I represent 2 comma 0, that means that the 4-gallon jug is with the 2 gallons of water and the 3-gallon jug is empty. Okay, so similar that one, if I represent 0 comma y, that means that I am emptying the 2-gallon in 4-gallon jug on the ground. So these are the production rules we are representing while solving this water jug problem. Once the production rules are ready, then we need to keep on applying these production rules so that we can get only 2 gallons jug of water, 2 gallons of water in the 4-gallon jug. So these are the possible rules we can apply. Means first we are going to apply this rule number 2, and then rule number 9, again rule number 2, rule number 7. And in this particular case, we can apply either rule number 4, 5 and 12, and here also we can apply rule number 9 or rule number 11. Nothing but the production rules. So what does it mean? First we are the initial state, given state is this one, 2 jugs are empty, and next we are pouring the complete 3-gallon jug full with water. Next the same water, we are we are pouring it into the 4-gallon jug. So what happens here, the 4-gallon jug is now going to have the 3 gallons of water, and this particular Y jug is going to be empty. And next again we are pouring the water into the 3-gallon jug until it gets full. Next what we are doing again, we are removing some water and we are pouring into the 4-gallon jug. So initially the 4-gallon jug is having 3 liters of water. Okay, now after pouring the water from this Y jug, this 3 liters is going to become 4 liters. So how can we say that it is 4 liters? Means the jug is going to be full. The first jug, as we know that it is a 4 gallons of capacity, then we can say that now the quantity of now the quantity of X is 4, water quantity. And next what we are doing? Okay, next what we are doing, next we are by applying this rule 5 or rule 12. What does it mean? Means we are removing the complete water and we are pouring it on the ground. When we pour it on the ground, what happens? The 4-gallon jug is going to become empty. So already the second jug, the 3-gallon jug is already having 2 liters of water. Now what we do? We will pour this entire 2 liters of water into the 4-gallon jug. Initially it was empty. Now it will become 2. The second jug is going to become 0. There will be no water in the second jug. So what happened? The initial state means the given state is 0, 0, and the obtained state, the desired state is 2, 0. So in order to solve this particular problem, first we have identified or we have defined some production rules, and by seeing the appropriateness, means which rule is applicable to that particular state, we keep on applying the such kind of rules. So it does not guarantee that every time all the rules which we have defined are going to be applicable. Okay, to this particular problem statement, only 2, 9, 7, 5, 9 and level are applicable. But if we are going to change the measurements of these jugs, again we are going to see the different sequence of rules here. Okay, so this is the way how we are going to solve this water jug problem. Okay, so this is the reference I have used while preparing this content, and we will come back with the other topic in the next coming video. Up to then, thank you.
Like, share and subscribe. Hit the bell icon for more updates.